Hello all. Today we are going to discuss a topic in removable partial dentures, and the topic name is indirect retainers. As we all know, there are different parts for a removable partial denture, especially a cast partial denture, and these parts include the major connector, minor connector, direct retainer, and indirect retainer. So we know what are the different major connectors which we use for the maxillary denture and the different types of major connectors we are having for the mandibular denture. Then we know what is a direct retainer, which includes your retentive arm, reciprocal arm, and the occlusal rest. Now we are moving on to the new topic, that is indirect retainers. So this is a cast partial denture. In this, you can see all the different components which are incorporated for a maxillary partial denture. And this is a mandibular cast partial denture framework. And here also you can see the major connector, the direct retainer, indirect retainer, and the things like that. So this is another acrylized one, which is having the denture teeth, which also attached to the cast partial denture framework. And by designing are intended to remove the casting and replace it into the mouth. So whenever we do a cast partial denture, we do the designing in the cast and we make a wax pattern, and that is casted and it is placed in the patient's mouth. They are not rigidly connected to the tooth or the tissue. They are subjected to movement in response to functional loads such as those created by mastication. Since it is a removable denture, we can't say that it will be a fixed one or it will be firmly attached to the remaining tooth or the underlying structures. The movement can cause generation of stresses which, if not controlled, can damage the remaining teeth and the supporting bone. So that is the importance of this component of the removable partial denture. So let us see what is the definition which is defined by the glossary of prosthodontic terms of the indirect retainer. So it is the component of removable partial denture that assists the direct retainer in preventing displacement of distal extension denture base by functioning through lever action on the opposite side of the fulcrum line when the denture base moves away from the tissue in pure rotation around the fulcrum line. Definitely, this is a very long definition, but if we try to split this definition into few parts, it will be more understandable. So the first one, it is a component of the removable partial denture, and that is the first part. Then it assists the direct retainer in preventing displacement of the distal extension denture base. So what it does, it assists the direct retainer, and by assisting, what happens, it prevents the displacement of the distal extension denture base, and it functions through lever action. So we know in physics we have studied about the different types of lever principles. So this component acts by the lever principle. So that is why in the definition it is saying that it functions through lever action on the opposite side of the fulcrum line. So definitely when it is a lever principle which is applied, we will be expecting a fulcrum, and this is a fulcrum line around which the denture will be moving. And when the denture moves away from the tissue in pure rotation around the fulcrum line. So by the definition, if we split it into different parts, we know it's a component of the removable partial denture. It assists the direct retainer and it prevents displacement of the distal extension denture base, and it functions through a lever action. And what it does is that it prevents the movement of the denture base away from the tissue in a rotation type of movement around the fulcrum. So in this picture, we can see the human beings have developed so many ways in which their work can be made easy. And this is one picture shows that a heavy object is moved by using a lever principle, by using a fulcrum onto which the lever is placed and it is moved. So let's see what are the different types of levers. So we are having three types of levers: class 1 lever, class 2 lever, and class 3 lever. So this is class 1 lever, and in the picture you can see there is a seesaw, and on either side of the See, so two persons are sitting in the middle. You can see it is a supporting area, and that forms the fulcrum. So in the lever principle, that is in the first class lever, you can see the top picture. F is marked as the fulcrum, and you are having the resistance or the weight or the load is represented by the letter R, and the force which is applied by the person as effort, E. Okay, so in the picture you can see that. So when it is converted to the oral situation, you can see the natural tooth which is remaining in the distal area. You can see the marking F. So we will be placing a occlusal rest in that area, and the occlusal rest will be acting as the fulcrum in the abutment tooth there, and the effort which is applied by the letter E, and the resistance by the class pump R. So this is the simple class 1 lever which is applied in the oral cavity. Then we are having the class 2 lever, where you can see from the middle portion the fulcrum is shifted to one end, and the resistance is in the middle, and the force or the effort is on another end. So the fulcrum is on one end and the effort is on the other end, and the load is in the middle. Here you can see a person trying to move something in a trolley like thing. So the force is applied in the wheel area, and the load is there, and the effort is on the other. And this principle is applied in the oral cavity when the fulcrum is at one end and effort at the opposite end, and the resistance is at the center. Now we have class 3 lever. Here you can see the fulcrum is at one end, and the effort is in the middle, and the resistance is at the other end. So in the denture also you can see when the patient takes a sticky food, the fulcrum is at one end and the resistance at the opposite end, and the effort is in the center. So the stress concentrations in the partial denture includes three types: vertical stresses, horizontal stresses, and torsional stresses. So it can be displacing or dislodging forces onto the denture. So here in this picture, you can see the different planes in which the partial denture is able to move. We can see that three planes are shown as A, B, and C. A is in the sagittal plane, B is in the frontal plane, and C is in the horizontal plane. So these planes, the denture is free to move from one side to side. So here you can see the rotation around the transverse axis. Transverse axis is a plane which is passing directly from the front through the midline, passing on to the back. So if we consider that in the denture, you can see the denture is able to rotate in the transverse axis as shown in the below picture. Now we know the rotation around the longitudinal axis. See here, the longitudinal axis passes from one side to the other through the ear to the ear in the picture diagram you can see. And the denture is also able to move in that way. Okay, it is rotating around that fulcrum line. So here, rotation around the vertical axis. See here, again, this plane is a horizontal plane which is passing through a section of the face. Okay, and the denture is able to rotate in a vertical axis like this. That means in the vertical axis, it is able to move in a horizontal direction. And the fulcrum line and the is the line which is passing from one fulcrum point to the other fulcrum point. Fulcrum point, we know it is on the distal rest, distal most tooth, the rest seat which is prepared on the distal most seat. So if you connect the distal most tooth rest areas, that line forms the fulcrum line. So the location of the fulcrum line for different classes of RPD includes class 1 passes through the most posterior abutment. See here, the line which is passing through the most posterior abutment is on one side to the other. And if the abutment tooth are placed a little farther also, the most distal tooth shows the fulcrum line. And here you can see this is a class 3 situation. A class 2 situation with a modification space. Here also you can identify the fulcrum line which is passing through the most abutment, most distal abutment, which can be used as a direct retainer. Okay, here in class 3 situation, it passes through the two principal abutments. See here, so this is the fulcrum line and the principal abutments forms the fulcrum point. And class 4, it passes through two abutments adjacent to the edentulous faces. So these are the different planes in which the denture is able to move. So if we move the fulcrum to a different area, the type of movement for the prosthesis or the denture can be managed. And see here, the fulcrum line has been moved from the most posterior abutment teeth to the front. So here is the position where we are going to give the indirect retainer. So let's see what are the primary functions of the indirect retainer. It shifts the fulcrum line away from the point of application of the force, thereby contracting the lifting forces and stabilizing the denture. The auxiliary function includes it reduces the anteroposterior tilting leverages on the principal abutment, and this is particularly important when an isolated tooth is being used as the abutment and the proximal contact with the adjacent tooth prevents such tilting of the abutment teeth as the base lifts away from the tissue. So the contact of its minor connector with the axial tooth contributes to the support and stability of the partial denture, contracts horizontal forces applied to the denture. Anterior teeth supporting the indirect retainers are stabilized against the lingual movements, and it may act as a auxiliary rest to support a portion of the major connector facilitating stress distribution, that is the lingual bar. It provides the first visual indications for the need to reline an extension based partial denture. So that is all with this topic, and we will meet with another topic the next time. Thank you.